Welcome, everybody. Tonight, we're going to be working on the Unit 12 content, which is tools for implementing AI. And a lot of this really actually focuses on um, comparing different coding approaches, basically, and then also looking at some of the modern ways that we do application development these days. Um, and it's a pretty exciting time really to kind of get started on a lot of this stuff because there's so many possibilities that are happening kind of simultaneously. And so we're going to basically look at traditional coding at some point, but we start by looking at what we call no code, basically creating stuff, and I'll call it apps, but it's not necessarily apps, but creating stuff without even knowing how to code. But I will caution you, and this is one of our takeaways from our advisory too, that you still kind of have to understand the concepts underneath to really leverage it and make it do what you need to do. We'll also look at this thing we call low code as opposed to no code. So meaning a little bit of code and how that combines with AI. And then we'll look at a couple of platforms. We'll talk about different websites, tools, approaches, ones that are popular. We'll look at the history of it and all that kind of stuff. So that's kind of the lay of the land for tonight. We have talked about a lot of topics here, right? So I'm kind of following the the stuff they're presenting here, but basically, looking at traditional AI approaches and the kind of AI that we're learning about. By the way, a lot of people in the field call this applied AI, air quotes, right? Meaning we're applying artificial intelligence to real situations, like we would apply computer code to real situations, like in a business or an enterprise environment to solve problems, right? As opposed to the generative AI, which is like make a goofy picture of me riding a horse, that kind of thing, right? Very different kind of methodology. We will look at coding and not coding, and also the kind of the in between, the thing I call low code, or people in the industry call low code. And we'll start with the no code approach, what it is and its history, compare it to low code and how they differ. And we'll look at some applications. And some interesting quotes here to start with, right? So this is the guy that's the CEO at GitHub. GitHub, if you're not aware, is an online repository for storing computer code. That's its primary mission. So what a lot of coders do is when they create software, they store it on the GitHub platform, and then it's easy to share with other people. And his quote is, "The future of coding is no coding at all." Interesting. But not exactly what our advisors were telling us, right? And the people that were there know what I'm talking about. And it says here, if you haven't heard of no code, you're not alone. So a lot of people never have even heard this concept. This is totally a geek thing. Like, you go to a conference and people will talk about it and you'll be like, no code? What's that? Right. And this is the process of really kind of building your understanding on it, because in the AI world, it really is important because a lot of work is done this way. I am going to play this video here in a second, but take a look at the quote here. No code development is an approach that allows coders and non-technical users to build applications through visual modeling tools and configuration. I still will argue that you still have to have a level of knowledge to go with it. Let's run this video. It's pretty short.
Small tool using.
It's not at the beginning.
I think that there'll be many people who have been in a situation like me at Product Hunt, where I'm saying, oh, this would be so cool if the developers just had like a little bit of time on a Friday to build this very small thing that would just help me, like save me 5 hours a week. And obviously developers are very sought after and they're needed for all the big stuff. For your request to then get put through and be prioritized and actually get shipped, it takes a lot of time, takes a lot of money. So for me, no code, if I could build a small tool using a few of the tools at my disposal to get that thing done, or like help me do my own job, that's a huge win for me, the company, the developers, everyone involved. So I think more of that will start creeping in. I think a large education movement needs to happen around what is possible.
Okay. And so, I mean, that's pretty simplistic, right? But you're getting this professional's opinion, right? So, I want you to start thinking about like what he's saying. If we have ways where we can accelerate our workflow and make things go really quickly, that also save us time in the future, that's time gained, right? That we can apply to either other problems or gain back our lives, basically. If you feel like you're working all the time, that kind of thing. Um, and this is kind of a disturbing thing, right? So, like, you guys are learning how to code in Python probably, and you're like, oh, you read a like quote like this, and it says the amount of programs available per computer is shrinking so fast that most computers in the future must be put to work at least in part without programmers. Okay, now that's weird, but I give you a little context. When I started getting into computing, and real frankly, when personal computers first came out, the reason people bought the computers was to program them, right? There weren't a lot of applications. People wanted to create stuff. They wanted to create games and they wanted to create software. And in many cases, you had to do that to even use the computer. So, like right from the box, you have to become a right out of the box. You have to become a programmer to kind of use the machine. And now, how many of us write code? Well, only silly people that are in IT programs studying to be coders, right? Um, all right, so things shift basically is the point. The no code market, right? And look at the dates on this. We're already past these dates, and this is where it's notable. So from 2017 to 2022, the market like like grew almost sevenfold, right? Huge. They give some examples here of some tools we sort of think of as no code. So and some of you may have even played with some of these tools, not even knowing it, right? Um, so the concept of cloud computing came back out in 1997. Um, and that was where we were launching applications out on the internet and people could just connect to them, right? And also store their files out there. That was kind of happening by the late 90s. Um, Salesforce back in 2000 had their thing called the end of software. And they have this acronym in here, SaaS, which by the way stands for software as a service. So in other words, instead of going to the store, buying the software like in a box or on a disk and installing it on your computer, now you just use the software online. And I'll give you a great example. When I first started computing, if I wanted to do email, I would have to download an email program. And then I'd have to figure out what my settings were for my email provider and hopefully they were right. And then I could send emails, but I had to have a piece of software for it. Now, how do we do email? Gmail, Yahoo, Hotmail, whatever. You just do it in your browser. That's software as a service. You don't install anything. You just log in and go. By 2003, we had WordPress come out, which is a web development tool, right? So you can build websites with WordPress, and a lot of the world's websites are built with that tool still. It's estimated maybe even as much as 2/3 to 3/4 of the world's website it's are built on top of that piece of software. Pretty amazing, right? And here's the fun thing about it. You don't necessarily know how to write HTML code to do it. It's helpful if you know, though. I would say that. Then we start seeing that no code started to pop up its head from Google, by the way. Um, and they started launching a bunch of tools that were like that. So they were pushing stuff out to the cloud, applications were running through the browser, and then people started to create little drag and drop interfaces for building things without you needing to know at all what you're doing. Like, for example, can I get a show of hands here really quick? Have any of you ever built like a Google form for anything? Nobody here. Okay. Chris, okay, one person. Yay. All right. But a Google form is like in the old days, if I wanted to build a form to put on the internet, so like enter your name, click your level of expertise, and there's a little slider and a box to type stuff into. Like you see this on a lot of websites, like a contact form, for example. You would have to know how to write code to build that. Well, if you log into your Gmail account, by the way, go to Google Docs or Google Drive, you can, aside from a spreadsheet, a document, and a slideshow, you can also create a form. You don't need to know what you're doing. And 5 minutes later, you're publishing it on the internet and collecting data. I was like, wow, like I don't know how to code, but I just built this. Right? Then in 2019, it kind of shot, going to the future here, we get Shopify, right? And I don't know if anybody here has ever tried selling stuff online and using Shopify, but it's an e-commerce platform that once again you can like take pictures of some product, type up some descriptions, set a price, choose your shipping methods or whatever, you know, and then all of a sudden you're selling stuff online and you don't know how to code at all. That's compared to like when I first built an e-commerce website and I literally spent months writing the code for it and it was really nothing special. It did work, but I spent months of my life building it. And now I can just hop up on a website, click a couple settings, and boom, it's there. Right. And what a revolution. And think about the timing of this. This is right before the pandemic. And then everybody, like the pandemic happened, everybody's like, oh man, I need a Shopify website. You know, that's kind of what happened. Um, the CEO from Microsoft, the guy who replaced Bill Gates, by the way, Satya Nadella, um, he says he's focusing on no code and low code tools. And this is built into their cloud platforms, by the way. And so Microsoft's got a lot of really cool tools. Unfortunately, a lot of them are not free. If we can demonstrate some of those as we move further into our AI studies, right, in this program, you will get exposed to them. But what they're doing is they're building these tools on their platform that easily interface with their other tools. So you can kind of build stuff once again with drag and drop, and they're calling it citizen developers. The market is growing quickly. Remember on the previous slide in 2022, it was worth like 30 some billion. 2 years later, it's almost double. Can you imagine like where it's even going from there? Yeah, the market's growing, you guys, and it's growing quickly. Um, so why do people do this? Um, all right, if you have a tool that requires somebody to have a high level of skill in order to use it, that means they need to go to school for a long time. They got to get experience doing it. Stuff might change, all this stuff. And then you have like this drag and drop interface. Oh my God. Um, you can use company resources better. It's going to cost the company less to use no code tools. So people can create stuff without a lot of effort necessarily in some cases and have it do exactly what they're talking about. But my Google form example is a great example of that. In the past, you'd have to have a developer that knew how to code the forms, and then it would have to talk to a database and yada, yada, yada. And then now all of a sudden, I can just hop up 5 minutes later. I've built a form. I published it on the internet. My friends are filling it out, and I have the data. Like what a difference, right? So much better use of company resources. In many cases, you can do more with those tools because they're really well designed by people that did know what they were doing. And you might be struggling for the right kind of tools, but because um, you're leveraging that expertise, you can do a lot more customization a lot more quickly too. So in other words, you can make it look good, behave well, and build upon it pretty easily. The speed of delivery is so much faster, and let's face it, folks. We live in a impatient world these days. Like people want stuff to improve, they want it to improve quickly. They don't care how it happens; they just want it to happen. But the fact that most of the creation is graphical in nature, so in other words, it literally is drag and drop in some cases. Um, it really speeds up that development. Um, a lot of companies are leveraging this. A lot of new companies are forming. I went to the Summerfest Tech Conference last year, and I went to this little talk, and I swear these guys must have been like 20 years old. So, I'm just kind of giving you an age. And they had developed a platform that leveraged a bunch of these no-code tools together into one thing and attaching it to AI and having people build all these like crazy apps. Like, what's your idea? Okay, let me show you how you can build that, and then you can put it out there and try to make money off of it. And like, they weren't spending months coding it; they were spending like a day or two, and that's it. And they're doing the same thing the regular developers are doing. They didn't have the, let's call it, ankle weights of having to go through all through the process of learning all the code and nitty gritty, right? And that's okay, right? That it's done that, but it gives people a chance to really do some crazy creative things and do them quickly. And who cares if it works? It works. Doesn't matter how it was created, right? All right. So the other comparable tool is a thing called low code, right? Okay, so that means there is some coding involved here. And this is kind of a big trend too. So we do some coding because we can get more precise control over code. And that's one thing you'll learn. Sometimes no coding and low coding will not give you exactly what you want because the tools are sometimes too generic. Low code, however, allows you to intermix it, no coding and coding, get the specifics you want, and still leverage the rapid development aspects of it, right? So here's some of the differences they're pointing out between no code and low code. So it says no code platforms don't require technical knowledge and thus are accessible to any end business user. And our advisory was saying different, right? They were saying it's really helpful if you kind of do know what you're doing, because then you're more powerful with it, right? Not that you couldn't figure it out if you're clever. That's kind of the point, I think. The low code approach still requires developers that know how to code and can work within a platform, right, to streamline the whole thing. And that's more of what we are hearing from our advisors, I think, is that kind of mix. So kind of interesting. Um, so when it comes down to like the actual coding, right, that you work with here, no code is basically drag and drop, right? You still have to have a logic behind it, but low code um, still is going to require that some of the key architecture is written out by hand. Maybe it's the formulas, or the math or something like that that's necessary. No code has these real high level tools, and we'll see this with the teachable machine later. And it's true with the open app thing that we're going to look at in just a little bit, um, where it really is like, oh, I like this background. I want these buttons. Here's my data. Here's my database connection. Boom, you're up and running. Right. And low code gives you that capability, but also allows you that deeper level coding approach. All right, take a look at this little uh, quote here. So 80% of IT and operations professional think no code will empower their operations team to get more work done. Uh, I think we were hearing that very clearly from our advisors. Um, and in an economy where things are uncertain and people are like, hey, we need more help, if they can switch to approaches like this and get more done, yeah. So the people that know about this kind of stuff will be the ones that leverage it. Um, so let's take a look at some tools that kind of fit into these areas, right? So like, it's not all just about AI, right? Because like coding and no coding affects all the areas of IT that that I'll say require application development. Okay, so websites are a big one, right? We do everything through the web. There's a tool called Webflow that came out, I don't know, maybe not even 10 years ago, that takes kind of like what WordPress does and takes it to a higher level. And it used to be that students in our graphic arts program here at Gateway would study traditional coding and website creation through WordPress, right? So kind of coding and not no coding. And then Webflow came out, and now they can create websites just as easily as like working Photoshop. Like, oh, hey, I want a button. Hey, I want to put a graphic here. They just drag and drop it in, grab a couple of handles. They don't write any code. Now, in the back of all that stuff, there is code being written, but they're not doing it. The application's doing it for them. Right. What's neat about this, right? And I'm not going to talk about every single tool on here because we could be here for half hour just doing that. But notice that in all the different categories here, if you're building mobile apps or chatbots or databases or e-commerce or whatever, there are no code tools out there. And this is a great listing of some of the more popular ones. Like if you ever wanted to build an app for like phones, well, here's some tools. Check it out. Maybe you got an idea. And if they're no code, all you need is the idea, folks. The hard part, really, it's not that coding's easy, but usually the hard part of having a successful app is the idea, is having the right idea. Because everybody, like, hey, I want to make an app that does blank. Oh, there's already 500 of those. Yeah, that's the hard part, right? Coming up with a new thought. Um, but if you're curious about playing with this stuff and you're like already like, let's say you're totally a database person, try Airtable. Yeah, totally. Here's some low code tools, right? So this is kind of interesting too, in that there is some coding involved with this. And, I was talking about like the Microsoft platform, so I'll focus on those. But like Microsoft in their Azure cloud, which is their cloud computing platform, has this thing called Power Apps. And these basically allow me to take like maybe a spreadsheet I have or a database I have, and then drag in a widget, connect it to my database, and then set up a web page for it that grabs the data from users on the internet and puts it into my database. There's a little bit of coding that you need to know, but generally it's mostly drag and drop, right? So this is an example. But if you're interested in exploring, once again, here are some great examples. Ones that I've played with on this screen, I've played with the Power Apps, I've played with the Google App Maker and FileMaker. I've played with all of those. All right. So here they actually provide some links. I'm going to click through the website just really quickly to show you how easy it is. I was exploring this later, so I already have a login. The point of this website, and this is called Open as App, right? And when you get to the screen, the reason I'm doing this is you don't have to sign up for anything, right? You'll notice, what symbol is this, by the way? That's the symbol for the euro. So this is a European website, so they want you to pay in euros, just so you know. But notice if you were a business or a nonprofit or an enterprise and you're really building apps and deploying them, that's not really a lot to pay. Right? But you can just choose the skip for now, and it puts you into their app creation environment. Now, the general point of this is that most of the time when you build apps, the apps either display information or they gather information or both. Most information is stored either in a database or a table or a spreadsheet, basically, like a CSV file or a JSON file or an XML file, or, but tabular data, basically. And most of the more difficult tasks in creating apps is connecting your app, the screen of your app, to the data that drives it. And this interface here allows you, for example, to very quickly build apps either for phones, for websites, or whatever. They have all these drag and drop tools, beautiful templates, and you can create stuff very, very quickly and not spend a lot of money, and it's easy to scale. So I encourage you to explore this. I don't have time to do a demo on it, but what we do have time to do is just kind of sort of quickly watch this video. So I'm going to pull this up on screen.
So you're already using ChatGPT, and while
and sorry about the ad, but I can skip it.
Hey there, it's Damien from OpenAsApp. Today we are creating an app with which we want to collect contact information of people with whom we want to stay in touch and keep them updated. So imagine you're a school administrator. You need to keep children's parents updated on the current status and also make sure you have all their current contact information. Collecting those information can be a really daunting and time-consuming task, oftentimes involving many tools and channels. Why shouldn't this be easier? Today, we're going to build a quick and easy app to improve the process of collecting necessary information and basically show you how you can do it on your own. So let's start the app creator from openasapp.com. and pick the file in the first step, which we already prepared for this tutorial. A simple contact form we built in our Excel spreadsheet. This is how it looks. Few input fields, first name, last name, email, some additional information. Let's proceed with that one to the next step and pick survey as the recommended app template because we actually want to collect the information in it. Now the only thing we need to do is to select the cells that we want to show in our app. So let's do this. Open as app will automatically recognize if those are input fields or output fields and also assign a.
I'm going to stop it there, but I just want to show you. I mean, this is what a 7-minute video, 8-minute video, and the guy's demonstrating a complete app build using no code tools, right? He's got a spreadsheet to start with. He's clicking a couple things on the screen. It's already kind of half built the app on the other screen already, right? So these are the kind of tools that are out there. And if you have some simple need like that, so like what was his example? He was like building this for like a school baseball team or something like that. They wanted to gather the parents' information, and then the app would automatically feed data into the spreadsheet. So the person who created the app, after they get the data, they just log into the computer, look at the spreadsheet, and the data's there. How cool is that, right? And on top of it all, when you're done building,
corner,
when you're
so
done,
we know what we are
when you're done building the app, it gives you a QR code, and people just scan the QR code. The app comes up on their screen. They fill out their information, and you're done. How cool is that? I mean, it really is pretty neat and smart, right? So feel free to explore this. This is a pretty cool one. I've never built anything in it personally, but I am intrigued to try it, and I think it might be kind of fun. Right? So if any of you do build anything with it, share it with us. Show it to us. Right? I'm just kind of putting it out there. Right. So time for a quiz. Right. We're skipping through the quiz really fast, but we're displaying the answers for all of those that are interested. Not that this stuff is important, but who knows? Maybe that stuff's on the quiz too. All right. All right. So just the comparison once again between no code and low code. No code, no coding needed. Low code, some might be needed, but both accelerate workflow quite a bit. So let's start looking at no code here again, and we'll start looking at some ones that are related to AI now. So this is where it gets a little more interesting for us. So let's kind of like dig in here because we're here to learn about AI. And if there's like no code tools for like building websites and building apps and databases, and wait, there's no code tools for AI, like hello, right? And I want you guys to start thinking about this. Now, if you got an idea and there's AI engines that you can leverage that are going to do all the heavy lifting for you, now you just once again you need the concept of what that AI is going to do. So this is a very high level look. There's several different screens here of these things, and real frankly, I have played with hardly any of them. So a lot of this is as new to me as it is to you. But take a look at some of these and what they do. So Clarify, I think that's how you say it, does natural language processing and computer vision. Create ML is for machine learning. And apparently it's built into Apple products like Photos and Siri. Interesting. Google has their what we call auto ML. So this is automatic machine learning. We're going to sort of play with a piece of that later. So this technology drives the other one that we're going to play with. But it includes vision and video intelligence, so it can analyze images and video. And it was in beta when this PowerPoint was put out, but might not be anymore. Does natural language and works with data, so that's kind of intriguing. There's this other one called Data Robot, and its focus, it looks like it's more data analytics focused. Okay, so it can be in the cloud, on-prem, or okay, that's pretty interesting too. We have Levity, right? Focuses on image, text, and document classification. And I want you to notice that, like, as we kind of look at some of these tools, what they might be used for. So Levity does custom models and flows and also includes a human in the loop option. So users have full control if the model asks for input. Okay, that's kind of interesting. Lobe is a product from Microsoft. This is for their image classification and object detection. And it looks like the classification piece was in process when they published this. We have Make ML, and you'll notice a lot of these are machine learning focused, right? Because that's really probably the biggest subset of AI, by the way, is machine learning. That one is for object detection and segmentation. There's a monkey learn, text analysis, data visualization, unstructured text, etc. And then we have NanoNets down there at the bottom, which is a computer vision tool. That one I've actually seen demonstrated, by the way. Some other no-code tools here. Obviously AI, that's a fairly new tool. All right, so that's a text-driven engine. We have Runway ML, and then we also have the one that we're going to play with later tonight, which is Teachable Machine, right? And the reason we play with that one is, well, for a couple of reasons. It's really easy to use. Like, you don't have to be really an expert at it. And Google is great about their user interfaces. It's very drag and drop. It really interfaces beautifully with your machine, and you'll see it working, and you'll go like I did, like, wow, this is really cool. Right? And you'll see what I mean when we get there. And you know, more importantly, it works in your browser. You don't have to download and install it or pay money for it. And it, you know, it's totally free. It is quick and dirty. Okay, whatever that means. I'm still very impressed with it, for sure. All right. So keeping it like down this path here, you know, looking at no coding in the AI area, kind of, you know, okay, so it says here, what are the criteria for a tool to qualify as no code AI? This allows us to build stuff, it says, from scratch, where previously we'd have one or more machine learning engineers to build it, right? So this is sort of people replacing in a sense, but really I think of it's more enabling, because most places really did not have machine learning engineers. They usually had coders that would do those tasks, you know, like, you're pretty smart, you know, computers, you do that. You know, that was kind of like what it was. It says it creates values, right? It's and it's not just for people in really big companies. Here's the beauty of some of this stuff. When some of these tools are free and they're just on the internet, or there's libraries that you can download for free and add to your program, folks, small players can compete against big companies this way. This is landscape changing. It really is empowering for competition, where normally you wouldn't be able to compete, right? Because you wouldn't have the people for it, basically, or the money for it. And you don't have to be technical, right? So you can kind of just, you know, build stuff that's AI driven, and you don't necessarily have to be an AI expert. I will argue it still helps a lot to understand all this stuff. Drag and drop interfaces, right? So like your tools are on your screen, you're moving around, you click on a thing, make a couple of selection, and it's just working. And the other aspect of this is the ease at which you can connect your information to data. Now, I'll just have you think, like, most of you have taken the Python class here, and even tonight in the data analytics class, we were taking the CSV file, right? And we're feeding it into an app. Well, first of all, you have to have the file, then you have to put it in the right place, then you have to write the code, hope your code was correct. We would still put it in an exception statement just in case it failed, right? All those tasks we had to go through. And one of the nicest things about no code development is, like, where's your data source? Okay, put in your username and password, boom, done. You know, it's like kind of that quick. Or you have the file, you just upload it, and you know, where people who learn how to code sometimes, like right now I'm teaching a Java 2 class. We spend 3 weeks on the database chapter, connecting the app to a database and then driving a GUI program, because it's technically challenging, right? The code's challenging, the technology's challenging. There's all these hoops we have to jump through. They are simplifying all of it, right? what they call the OOTB, out of the box functionality, right? Um, you don't need to like do add-ons often, right? A lot of it has all the stuff in it you already need, and it's built that way on purpose, and that's so that you can just get to like creating things, right? The other aspect that, and this is true of all types of coding, by the way, no code and regular coding, is once you've built something, you can reuse it with something else. So if I build an AI solution that can, find something on a map and it works, well, now I can take that thing I built and I can add it to my other app that does the same thing, right? I don't have to rebuild it. You can reuse your tools over and over again. One another big challenge, and we learned that in the data analytics class tonight, is like learning how to do a GUI program where you're creating a user interface. It's cumbersome when you have to write it out as code. We wrote out all that code, we'll copy paste it, but whatever. We wrote out all that code and we had stuff that looked pretty primitive. Wouldn't it be slick if you just drag and drop a couple things, click a couple buttons, make a couple of check boxes, and beautiful, right? Why wouldn't you? Right, absolutely. The other thing is a lot of these tools work on any platform. So that means phones, tablets, computers, Windows, Mac, Linux, doesn't matter, right? And a lot of it pushes through the browsers or other uh, ways of doing it. In terms of like when we go through the process of project managing an application build, right? So we learned about like the AI project process, right? And we learned about agile development and waterfall and systems development, all that stuff. No coding totally accelerates this, and it really fits well into the agile approach. Because if it's just a drag and a drop, and somebody's like, well, wouldn't it be better if this was over there and we added a thing that did this? And it'd be really easy to change. I mean, it speeds up the application development so much. Um, it's kind of crazy, actually. They have the scalability thing at the bottom. And what that term technically means is you build an app, and then if it's really popular, you can give it more resources and have it automatically handle more traffic. And what I always use as an example for my web students is, do you ever see that one commercial where they had like some these people like launch their website and they were watching the screen and they got their first sale and they're like, yay, we got a sale. And then all of a sudden they had 1,000 sales and like, oh no, how do we handle all those sales? They weren't ready to scale, right? And scalability is the thing that's really mostly possible because a lot of the no code stuff does happen out on the cloud. So all you have to do is whoever your cloud provider is you just flip a switch and get more resources. Yeah, you pay more, but you don't have to like move it to a different computer system or buy new software or get a better internet connection. It's all out in the cloud. It's easy to scale. We were talking about this too, right? Getting connected to communities, right? And this is a great idea if you're in IT, anyhow, right? There are communities that are building, even here in southeastern Wisconsin, both academically and professionally, for people that get together and talk about AI and machine learning and automation and all that kind of goofy stuff. There's meetup groups. The no code communities are pretty vibrant. And I would suggest no matter what area of IT you go into, it's really wise to connect up with the people in your area. Why? Because you might be able to connect, like you're a student right now, you might be able to connect with people that work at some big companies in our area. And guess what? Maybe later they'll have a job. I'm just throwing it out there, right? Or you make a friend and they get a job and then they hire you, or recommend you. You know what I mean? It is small connections, ones that we often ignore that often lead to big things. And you never know, right? And um, so um, so some of the things that they offer in these types of communities, right? So they sometimes have tutorials and they talk about tech and people give you their opinions on what's good and what's not. Um, and there's usually websites that go with them. Some people like meet up on Slack. Some people have Discord channels, et cetera, et cetera, et cetera. Some people meet in person. It's all out there, folks. Here's some, like, if you're really want to walk this path, they're giving some examples of some no code communities. I'm not going to talk about each one of ththese, but I'm just showing you the list here. 100 days of no code, new code, no code list, no code.tech, no coders, makerpad, um, and they even tell you, what different languages, how many people are involved, and I'm sure those numbers are bigger now. Um, so like people who are getting these types of jobs, and this is a hot area of recruitment, by the way, um, and often, I'll be real frank, often all it takes to get these jobs is to demonstrate that you've already done it. You necessarily have to go to school. If you've created something and you can show it to somebody, like, okay, well, you got it. All right, we'll hire you. You know, it kind of harkens back to the old days of this field where it was, I kid you not, when I was going out into the workplace, sometimes it was just like, computers, all right, you're hired. It was like that because there's so few people knew them. But here's some of the job roles that you could look for example. So like, you know the thinking is, oh, hey, I got to look for an AI position. Maybe not. Maybe you're looking for a developer spot or an app builder or a systems engineer or an analyst of some sort. Those are all employable positions. Um, Now, this is really kind of an interesting quote. The IEEE is an international standards organization for people in technology, by the way, if you're curious. No code development is also a solution to a supply and demand problem, a rising demand for generating more software, but a limited number of developers who that can create that software. So one of the reasons this exists is we can't generate enough coders. This is a problem we have even here at school, right? So like even right here in our 3 county area, we're seeing Walworth and Kenosha counties. There are probably several hundred open positions for software developers that the companies in our area cannot fill because they can't find qualified people. These are full-time jobs with benefits and decent pay, right? So can you understand why companies would then go, you know what, this no code thing, if somebody kind of gets it and they can do a no code thing, oh my God, right, they're going to hire you. So that's kind of where we're leading with this stuff. um all right, here's some examples of how no code is being used by some larger and prominent companies, by the way. And you may already be affected by this, right? So like we were talking earlier, how our one advisor that Laura talked to indicated to us that like if she applied for that position online, she'd probably get filtered out, right? Because they have some sort of a tool that they put in place. And I would bet it was built by a no code kind of environment. They probably just had a screen on Indeed or Monster that's like, what people do you want to include, or just, so they might be looking for bachelor's degree, 5 years experience, certain languages, whatever. But look at some of these usages, and I think these are interesting. So looking at documents to make sure they're complete, like, hey, fill out line 45. Oh, you forgot line 45, fill it out. Right? Or get customer insights at scale. So classify incoming product reviews, client call notes, customer feedback, um, categorizing Instagram photos. Interesting. Um, Check onboarding documents. So like maybe you are signing up for, I don't know, a new doctor's office or a new organization, and they have you fill out a bunch of forms, and they might have a tool that checks your documents to make sure they're complete so they don't have to hire a person to do it. Or how about categorizing email by content? Gmail does that, right? They have their like promotions and social networking, all goes into different folders. Filter startup databases, content moderation. Like you think all that Facebook stuff happens automatically, or they have a person sitting there taking each like thing you want to unfollow. No, they're doing it with software. The one I think troubles a lot of people is that last one. It troubles me a little bit that you put in an insurance claim and they're just like, this one's not real. Bye, right? And that's why sometimes you really do want to talk to a person at an insurance company. All right, we're reaching kind of a logical stopping point here, so I'm gonna go through these next few slides and then we'll take a break. I know you guys are probably getting tired of hearing me talk already. Um, but now we're starting to take some of these tools and intermingling them with generative AI, which makes it even more scary or cool, depending on your the way you look at it, right? All right. So if we start taking no code tools and starting to apply Gen AI techniques to it, what kind of stuff can we do? All right. So one thing is data entry. All right. So generative AIs are great at either grabbing data for you, synthetically creating the data, or finding the data and pulling it together. So, for example, when we did that exercise in the data analytics class with the population of countries and their growth rates and their continents, you know how I created that data file? I asked an AI to create it for me. Yeah, I didn't type that up. Right? And I didn't download it from anywhere. I asked it to do it. So that was my data entry. Okay, great. Right. Um, guess what? The exercises from that class were also generated by an AI. I experimented with it. I had my old exercises, they were kind of lame. I thought those exercises were cooler, so I let it create some code for me. Right. Granted, I studied the code and made sure it was all good. Testing, where we can actually use AI to test the code that we're creating, whether it's no code or real code. Because guess what? Testing software is a job too, right? So, like somebody creates software, somebody's got to try all the features to make sure they all work and they work correctly and don't fail under certain circumstances. So, you can task an AI to do that. So, the benefits, yeah, you can create stuff faster. You can, okay, if you're doing it faster, the price goes down, right? Because you're not paying people hours to do it. Sometimes you get better quality, right? Because you're working with the AI, and it's going to be maybe more on point than you are. It's not going to make the mistakes that you're making. You do have to be careful. AIs can, they call it hallucination, right? They can hallucinate information. And an enhanced agility, meaning that you can pivot and make changes much faster to the stuff. One really cool platform, and remember I was talking about those young people that were at that Summerfest Tech Conference. This was one of the primary tools that they used, right? So Bubble has an AI model built into its engine. So I can do no coding. And then if I want the no code thing that I'm building to also leverage AI, it's just a simple drag and drop into your project. This is kind of scary stuff. This is one of the preeminent platforms for doing this kind of work. The demonstration that I saw last year, I was very impressed. Right, it did make me want to try doing stuff. I seem to always be too busy professionally to do that or personally, but you guys might have the time. Right. So Bubble allows you to build the app. It also hosts the app. So once you have it built, you don't have to deploy it to Amazon Cloud or to Microsoft or something like that. It's all within the platform. And it very seamlessly ties into data and other apps. And oh my God, if you can build an app and also add AI to it, like how cool is that? It really is pretty darn cool. So that's a really interesting little platform. All right. We are at the point now that we are going to take a break. So I'm going to stop the recording or pause the recording here. All right. So these are the key takeaways here as we're coming back from break, talking about, no code stuff and the advantages, basically. We are going to move forward here. Here's the question on the screen. And okay, so now we know no code is out there, but is it really the only way? And you know what? It's not, right? And most of you are just coming out of the data analytics class where we are doing Python GUI programming, and you saw like what's involved there. And keep in mind, Python is a modern easy, intuitive language to learn, right? So other languages are not necessarily so easy, right? And that's still pretty complicated. It's complicated to do, but you know what? It's not going away. Okay, so we're going to talk about Python. That's like our main focus here, but we're also going to talk about coding in general and why it's important and why it's not going away, right? Um, Computer programming, and they have this little video here, and I forget how long it is. It's only a minute.
On a computer, you can do all sorts of things: play games, do homework, or talk to friends. All these things are done using computer programs. But what are programs made from? Computer programs are made out of their own special language called code.
Please what, Mr. Mouse?
A computer can't think for itself, and you can't talk to it like a person. It needs computer programs so it knows what to do.
Step 100. Backwards.
Code is made out of words and numbers. Sometimes it is made from words you already know. You can learn how to put these words in order so the computer understands what to do.
Step 10. Forwards.
You can change the numbers and the words to choose what happens in your own program. There are lots more things you can do. It is your code, so you can choose. It's up to you and your imagination.
Yeah, and you know what's funny about this is
On a computer.
Okay, sorry, but when I first got introduced to writing computer code, I wasn't really quite ready for it. And fortunately, I had some really good instructors, and I think which instructors you get when you learn this stuff does help, right? Because not everybody's good at teaching everything or explaining the concepts behind it. Sometimes people just like read you what's in the book and that's all you get. But my very first coding instructor said to me, or really said to the class, computers are just a bunch of parts that are put together. They don't do anything. They need instructions. We write the instructions to tell them what to do, right? And yeah, that's completely it. And the instructions that we write ultimately get converted from the syntax of our coding language into a binary file that speaks to the machine on the circuit level to make it do all the little things that it does and the maneuvers that it takes even to move the mouse across the screen might be 10,000 lines of code, so it's kind of crazy, like the detail that you need, but it is a learnable thing. But basically it's a set of instructions for the computer. It says what actions to take. Writing code is like creating a set of instructions. Yeah, absolutely. Code powers our digital world. I mean, all of us rely on the internet, all of us rely on our phone, our computers, and especially in these fields. I mean, without those tools, we're not working and we're not doing anything, basically. Every website, app, calculator, even microwave relies on code in order to operate. Heck, even your cars have computers in them. Modern cars sometimes have 10, 20 computers in them. That's really crazy. So why do you learn to read code in the context of AI? All right, so they're going to give you some scenarios here. Okay, so they're saying one can treat AI applications as black boxes and get the job done, right? But errors can go unnoticed, and that gives you bigger problems down the road. And it makes you oblivious, right, to possible ethical issues that you're creating out of AI applications. So they're giving you the scenario. You've made a computer vision recommendation AI system using no code. The system is biased towards male candidates and candidates with more than 5 years of experience. Now, this sounds like that job thing, right? Totally, right? All right, so the following can be said about our computer vision application. AI produces biased outcomes. It can, depending on the data that we're feeding in. So if we're putting bad data in that creates biased outcomes, it's going to make bad decisions that might put somebody out of a job or never get the job in the first place. And so basically what they're saying here is it can basically enhance bad ethics, right? We really don't want it to be biased towards male developers, right? And I'll tell you why, and I say this to all the females here in the session. Women solve problems differently than men. They do, right? Anybody that's married knows what I'm talking about, you know. And women are like, yeah, damn straight, that guy doesn't know what he's doing half the time, right? All right. So, in fairness, right? I mean, there is kind of like this historical legacy of our society that we're kind of shaking off right now, right? And that is that we really should be more equal. Doesn't matter what gender you are, or race you are, or age you are, or whatever. If you can do it, you can do it, and that's all there is to it, right? And but the biases still exist. Some of them are programmed into us. Um, so here's some of the takeaways. So they're talking about development support. So AI required dedicated planning and development cycles, right? Just like any other development does, right? um, Adding AI into software is a big thing, but knowing how to read code is necessary also, and then combining the two together takes an expertise as well. And I think that once again, we're hearing that real strongly from our advisory. Yeah, we'll use AI, but we still know people that understand what it's doing, right? Otherwise, what's the point? Um, the one thing that you can do, right? So they're like taking a look at like how long it's taking for a project to be built, and pointing this one. Um, you need to understand like if a project's mid-process, what stage is it at? And this is one of the frustrating things about building software, building a website or an app, is how much that time goes into planning, how much time goes into just like what features you want. And then like as many of my project students discover, right, like when I do like web projects or software project classes, that the coding parts maybe like 20% of the whole project. It's all the other stuff that goes around it that takes a long time to make sure that it's all okay, right? But if you know how to code, it kind of changes the whole process. Another big aspect is getting AI in on the mix um, to do testing and research on your code, right? So um, here what they're showing is like this part of the process, the testing process, you have to put algorithms into a real system and check it. And then sometimes you have to tinker or like tweak stuff to get it to run right. So my comparison would be like, I built a motor for my car, but it's not quite tuned right yet. I got to tweak a couple things to make it, be as good as it could be. And what they're saying is the technical knowledge is still important in this regard, and AI is not really going to necessarily replace that. All right, when you learn how to code, and I want you to notice here, these are, this is kind of a bad graphic. This is from September 24th of 2020. I would say that this is relatively still true, but notice how we have all these different languages, and notice that we have JavaScript way at the top of the list. JavaScript is the programming language that runs the internet. So when we're on a website, JavaScript is almost always there. That's why that's so popular. Python is right behind it, right? And I'm going to tell you that since 2020, Python has only gained popularity. So has JavaScript, though. So those two are probably still at the top. Then we have our traditional programming languages that follow: Java, C Sharp, C and C++. We call these our C style languages, and this is for compiled applications. And you can see where these are used, right? Most popular, okay, JavaScript is for web. It's not really used to build machine learning. If I know Python, it's very popular for machine learning and IoT. It has grown to create all kinds of stuff, but it's where it's most popular. So it depends on the kind of thing you're building relative to the language that you're using to build it, right? You'll notice if you're building stuff for a regular computer, which languages are you using? That's where we're doing like desktop. Or hey, I'm making a video game. Okay, I'm going to the traditional languages for the video games. Um, if I'm building websites, I'm using PHP or I'm using JavaScript or I'm using Ruby or one of these others. And there's a bunch of languages. Now, this is just a smattering of how many programming languages there are. I think if you guys took the Python class with me, I did a Kahoot where one of the questions was like, how many coding languages are there, right? And I think we have like over 700 are known, and there's probably more, right? And those are the ones that are known. Um, so kind of interesting. Um, but relative to the field that we're in, which is both AI, data analytics, data science, look at the three languages that are most prevalent and then understand why we teach those to you in this program, right? So 93% of data scientists use Python. More than half of them use SQL or SQL, which is how we program databases, right? Because we need somewhere to store information and pull it back. And then we have this other language called R. This is a class, by the way, this class is being offered in the summer, the R programming language, which is required in the AI data program. And it's basically a variant of Python, by the way, but it's designed for building um, graphs and charts and doing data analysis. But it is technically a subset. But with those three, and I'm going to tell you, all of these languages are highly employable. But I had one of our advisors, and this was at a advisory meeting maybe 3 or 4 years ago. He was like, "Yeah, you guys should totally add R to your program." And I'm like, "Why?" And he says, "Like, man, in California, if people know R, that's enough to get like a $200,000 job." It's kind of, that kind of thing. So few people know it, but it's really important for data analysis. So that's why we teach it to you. When we look at Python, why is Python had such prominence in this field? Well, we'll just go down the list here in order. It's easy. It's easy to learn. Now, you guys might not feel that when you're learning how to code in Python. You're like, that's not easy. It's like, it's easier than other languages. Let me tell you, talk to my Java students and then talk to my Python students. Python is much easier to learn. It's expressive. You can kind of sometimes guess at the syntax and get it right. There's no cost to it. It operates at a very high level. Portable means you can put it on any operating system. It's object oriented, like all the traditional languages are. It's extensible, meaning I can add libraries and tools to it. So if I want to add AI to my application, I find an AI library and import it. That's all it takes, right? And you just use it. It's embeddable, so I can add it to websites. I can add it to apps. I can just load it on a regular computer. It's interpreted, meaning it's not compiled. That's the weirdest one to explain. But a traditional program that you create will have what we call an executable file, an exe file, or an app file on Mac and Linux platforms. And those are files that are binary. They're converted to code the computer understands, but basically takes your code, converts it to the binary, and then the computer can run it. Interpreted means it just executes the instructions. It doesn't turn it into a binary. That's what makes it so portable. And there's all these discussions about it. Most traditional programs would say interpreted programs are terrible, they're inefficient. But you know what? That's changed now. So you can write the set of instructions, and as long as you have the libraries available, it'll run. Right? Very large standard library. I can do GUI programming with it, and it's dynamically typed, meaning that's like where I can take a variable and throw in a number and then switch it to words and then switch it to a list and then switch it to an object. It doesn't matter. It doesn't care. Right? That's what they mean by dynamically typed. You can throw whatever you want in that variable. It'll work. Yeah, that's fine. In Java, that's not how it goes. That's one of the reasons why it's so easy. Another reason, Python has a lot of tools. So like one of the big contributions from the Intel Corporation, where we're getting all our materials from, is they have an AI machine learning library called OpenVINO, right? This is free and open source. It's one of those libraries I can add in, and I have AI tools. Python is ranked high in the IEEE rankings because it is so heavily used in data science. And because of its simplicity in coding, and for whatever reason, people have latched onto this. And it's not you can't do this work with other languages, but when we do pretty much any machine learning, deep learning, AI, whatever, it's almost always in Python that it's developed. Um, Python is used in a lot of different applications, right? They showed like where it's most used, but I can kind of do anything that I can do in any other programming languages in Python. No problem, right? It's just a matter of applying it. People use it in all sorts of different areas. Um, and yeah, we're seeing like in the web area, it's starting to take over on the back end. People are starting to write games in it. And heck, the AI thing alone is the reason to learn it. Yeah, we're going to skip the discussion and we're going to move on. And now we're going to kind of look at this differentiation, and we're doing pretty good on time, by the way, if you guys are wondering. Looking at like comparing, like if we're building stuff with no code using AI versus doing traditional approaches with AI, and how does that look as we compare them, right? So take a look at the traditional AI process. So this means we're writing code from scratch. We might be using libraries or whatever, but generally speaking, if we're building like models and all of that stuff, look at the process. So we have to prepare our data, we have to build our features, we got to do our pre-processing, we got to select which models we're using in machine learning, then we tune our parameters, then we train our model, we deploy the model, and then we finally use it. Check out the no code approach. Find your data, upload it, drag and drop which models you're using, take a look at the results, and you're up and running, right? So the no code thing looks very attractive, and that's why a lot of people are using those tools. Right? All right. Now, it doesn't mean that traditional approach doesn't have value. Okay. Look at the advantages of the traditional approach. Unlimited functionality. So if your drag and drop tools are missing some features, well, if I'm coding, I can create those features. So I can get really particular and create stuff that exactly meets what we need, right? And that's a really, really big thing. And so that way we can deploy it any way we want. We want to put it on a phone, we want to put it on a tablet, we want to put it in the cloud, we want to put it on a desktop, a Mac, or Windows, whatever. We can do all of it. Doesn't matter, right? Because we're coding it, so we can design it to work there. If you build the code yourself, you own it, right? It's not like you're using the same tools everybody else is using and then wondering why your app looks just like the other person's app and does the same thing. You custom created it. There is a process that's been in place, right? The traditional waterfall approaches and now agile methodologies that companies have been using for decades for building software. Those procedures work. That's how we got here, right? In the first place. And that's well established. And a lot of companies don't want to give up processes that work correctly. Like this process works. It might be slow, but it works and it works well, right? So they stick with it. Disadvantages. All right, well, it costs a lot because I have to have the people that are trained, I have to have the right gear. It takes a longer amount of time, right? And so slow to market takes a longer amount of time. So like if you're developing a piece of software, it can literally be, a few months to maybe a year. I'll give you an example. When they launched healthcare.gov, do you guys remember that at all? Any of you? Probably not, right? But they estimated it would take a year to build it. It took two and a half. They estimated it would cost X amount of dollars. I think it cost 4 times as much, right? Yeah. And then when they launched it, it still wasn't working right. They had a lot of bugs to work. But think about it. It's a very big, complicated system. So that's the why. It requires skilled resources. You got to have people that know what they're doing, and have to also keep up on, the technology. And then usually you have to have a whole team of developers. You're not usually, company's not going to hire one person that does it all. That's just kind of impossible. So you get people that are very specialized into certain areas. And we talked about that in data analytics, right? You might have people that just create the user interface, and other people that deal with the database connection, and other people that write the math equations, and other people that create the data, and they're all working on the same software together, right? So looking at no code, all right, easy to pick up if you don't know how to code. It's faster to create, doesn't cost as much. You're offloading some of the development resources. So in other words, instead of like investing in the infrastructure, most of the stuff happens in the cloud. So I don't have to buy the computers or the software. I just use the tools through my browser and it works. And often you can add this to what you already do without hiring more people. Okay, not good for people looking for work, but you do get people in these departments that don't want to learn it or are retiring and they look for new people so it's helpful to know. Here's some of the problems with it though. Sometimes you can't get exactly what you want. You want the app to do this and it doesn't. And I'll give you a website example because that's like more my wheelhouse, where people will use WordPress or they'll use like Squarespace or Wix or Webflow and they create this beautiful website. And then they're like, oh, now I want to sell stuff and I'm not sure how to do that. Like they were able to drag and drop and make a beautiful website, but now they can't make it do anything, right? So then they call me. Then they pay me big money to add those features, right? Some of the platforms that you use for no coding forces you to use that company or product's solution. So in other words, like if I build that like open as app thing, like with the spreadsheet tool that we were looking at earlier, when I want to like get my app out there, I've got to use their stuff. So if I want to make money off of it, I got to pay them. Right. If you guys ever did like a website for Squarespace, it's like that too. As soon as you start like making money or you want your own domain name, you got to pay them. Right. Yeah, all the stuff starts looking the same. So if you go to a website and it looks just like somebody else's website, or you see somebody's app and it looks just like somebody else's app, it's not a mistake, right? That they're trying to copy each other. They just use the same tools to build it. They have like 3 blocks to work with, and so they're just putting them together in different orders. It is also with some of these newer tools, sometimes you cannot integrate with old technology. We talked about like, that IBM platform, right? And how that's really antiquated, but at the same time, it drives like our whole financial backbone of this country, like all the banks and insurance companies and stuff. And if I can't integrate with that, well, what good is it? Right. Yeah, that's kind of a thing. And then sometimes some of these platforms have limited scaling. So we talked about before how easy it is to scale, but not always. Some of these companies don't have that horsepower to like if your app got really, really big and popular and you're using all their tools and they're like, I'm sorry, we're at our limit. We can't give you any more. Well, then, okay, they're kind of ruining your product then, right? You can't make it bigger. So that's a concern. So that's why people still appreciate, the traditional approach. They do make it come across here, and I just want to be really clear on this. This PowerPoint makes it seem like no code is the way to go. That's not how a lot of companies look at it, though, right? I think there's a hybrid happening. I think the ones that tend to go no code completely are the ones that are new and don't have legacy systems. Anybody who's got a legacy system probably is doing hybrid. Right? This is kind of a quick comparison. All right, so what I think this statement's really true. And as I look at it, it says this movement has empowered the teams closest to the customers to control of everything from marketing to analytics, freeing up us developers to work on the core product. I do think that that's true, and I think that that's why a lot of people are looking at it. Now, so they're saying now the trade-offs of low code versus high code include simple stock-looking interfaces, less customization, harder integration with legacy systems, and fewer hosting options. So If those are concerns of yours, and they are for a lot of big existing companies, then it's a deal breaker in many cases. If you're a new company spinning up and you can work in the completely no code or low code environment, man, you just go for it. Why not? Right? The scalability is probably the only concern then. All right, so now we're going to look at some of the tools, and when we get done looking at some of these tools, we'll actually play with the Teachable machine thing from Google. But I just want to kind of show you some of the stuff here. Now, this is really kind of a mix of this listing is kind of a mix of different types of tools, right? They're not like AI tools. Some of these are just pieces of software, by the way, and other are website platforms, I'll call it. So for example, in the no code area, right, we'll see stuff like WordPress, and this is to build websites. This is to do e-commerce. Here's another e-commerce tool. By the way, that plugs into WordPress. And then we have some of these other, like, I'll call these more like drag and drop no code tools for doing both websites and apps, mostly the ones in that second column. Then we have what we call the low code tools that often can integrate well with legacy systems, so they can draw on a legacy system data, and then they have some drag and drop in there, and maybe you have to do a tiny little bit of coding to connect things. Probably the two big ones here are the Power Apps app sheet from Google, and Zoho is pretty big too. And then in the traditional software area, now think about this, folks. Those of you that have learned how to code Python and probably did it with me, a lot of the names here kind of resonate. I do really wonder why Linux is here, because that's an operating system. That's like saying Mac OS or Windows, so that's kind of weird. But Dreamweaver is for writing web pages. GitHub is for storing code on the web. Visual Studio and Visual Studio Code are coding engines. Notepad++ is just a text editor, and Atom is just a text editor too. But there's lots of tools, right? So like when you're coding traditionally, that's like the stuff we were doing in the data analytics class tonight. You find a coding engine that works. Could be Visual Studio Code or Spider or Jupyter Notebook or whatever. Doesn't matter what it is. As long as it can access the libraries, type up the code, and run the code, you can create software. That's the traditional approach. The higher level tools, depending on what you're building, once again, examples of the tools, and you should explore. And as we move deeper into this program and these courses, you'll start being introduced to more and more of these. All right, so they're taking a look at how no code revolutionized both building websites, email, and data analytics. So that these are some little quick timelines here, by the way. So they're showing back in 1993, Tim Berners-Lee. It's not Al Gore who invented the internet, by the way. He didn't invent anything. He didn't invent the World Wide Web. It was Tim Berners-Lee who invented the concept of the World Wide Web, where we can have a web browser, a piece of software that can surf the contents of the internet and dynamically link you to a website without needing to know its numeric server address, how to log into it, or any of that stuff. So he's really kind of the genius behind it. And it's because of him that we use our web browsers. You know, the web browsers were all built on his original code. And he's a very interesting character if you ever look him up, and I would encourage you to read up on him if you can. Brilliant mind, but he has a horrible stuttering problem. You know, it's really weird because like sometimes he'll speak and he's talking fine, and then he gets stuck on a word and can't say it. But his mind is really razor sharp. So the comparison they showed here is that he created the World Wide Web. About a year later, Google released, or not Google, excuse me, Yahoo. It was GeoCities, and then Yahoo bought them. Created a way for people on the internet to create like really quick little websites without knowing how to do anything, right? And a lot of people used it, right? And it was pretty easy to create stuff. By 2003, WordPress launched, and almost immediately, all the web developers that didn't want to code switched to it. And as I mentioned before, WordPress, even to this day, is a huge market share. A large majority of the world's websites run on that platform. And I always tell my web students, it's like you can make a whole career of just working on WordPress, a whole career. In 2017, this new product came out called Webflow. As I mentioned earlier, our graphic arts department switched to that product for its graphic students rather than teaching them how to code. It's all drag and drop, very, very powerful at the same time and really pretty slick to use. They did have all these other no-code builders. Some of these are out there, and maybe some of you have tried, like Squarespace or Wix. If you want to build a website and never, they don't even cost money. You can just go to their website, create an account, and build a website, and have it up and running in minutes, literally. Right? It's when you want to do something powerful where it fails. Right? In the email area, we first came out with the concept of email. Kind of goes back to the early days of the internet. Was basically the early 70s when email first started happening. And then the first marketing campaign on email went out in 1978, and it generated a huge amount of sales. Really kind of interesting. People didn't even know email was around back then, but it was. By the mid 90s, we had kind of the home internet revolution. Everybody started getting on like AOL or, all these different services, basically getting online, and people started to email. By 2001, MailChimp came out, and that automated email marketing. And now we have companies that, if you dread looking at your inbox and all the spam that you get, right? Why do companies do that? Well, the same reason they send junk mail to your mailbox, for real, because it works. They wouldn't do it if it didn't work, right? Every once in a while, you get a 50% off sale at Penny's. I'm there, yeah, and I'm riffing off at airport there a little bit. When it comes to analytics, right? So this is an area that's closer to what we do. In the 90s, they came out with this software called SAP, right? And a lot of companies still use it, by the way. And people started using the data inside of that platform to gather business intelligence and make decisions on it, right? By the late 90s, early 2000s, they came out with Tableau, and that's one of the products that you're going to learn here. It's a product that basically kind of is a hybrid between like a spreadsheet tool and a visualization tool. So it creates a lot of the data dashboards that we see online are created with Tableau. Comparable product is Power BI from Microsoft. They created this other little feature called VizQL, so that you could interface with databases a little bit better. And then as you go through the timeline there, a lot of this stuff started switching over and getting AI engines driven behind it. So in the late teens, we started seeing that creep into data analysis, and that's now firmly in place and heavily used, by the way. So AI is creeped into data analysis. So here's what some people are saying about no code for the future. I'll just let you kind of read that yourself real quick. So people do think that you don't necessarily need to know how to code for the future. I'm still going to argue that it's helpful. So you make your own decisions on that and go out into the workplace and you'll see what I mean. All right. So now they're talking about when to prefer no code or coding, right? How do you pick between the two? And you have to ask yourself some questions. And real frankly, take a look at the tasks that you're doing, what kind of project management you're working with, what kind of tools and information architecture you have at your institution, and are those tools and software and hardware appropriate to the problem that you're trying to fix? Or does it make sense to switch to a no code, maybe AI based tool in the long run? There's a lot of questions to consider, and companies do proceed very cautiously into these spaces. It tends to be newer companies that are really adventurous with it, real frankly. Now, when do you choose traditional development? When things are really, really complicated and technically detailed, right? When you don't want others to be able to have access to, to your app, so in other words, you created it, you have complete control of it. Nobody else can use the same tool you're using because you created it, and that's a really big one. And because you're customizing it, it probably um, has more capability to interface with a lot of other systems because it can be coded to do so, right? Where some of the no code tools might not. Here's some examples here. I'm just going to quickly put these up on the screen. There's kind of a series of these coming up here, right? So what skill sets, how much time it takes. I think an interesting metric at the bottom of the slide that 80% of projects are not delivered on time when the traditional route is taken. Interesting. Okay. So people always underestimate how long it's going to take. No code, bullet at the bottom here, 10 times faster compared to traditional development. That might be a big enough selling point for most companies, especially new ones, to use that approach. Which tool you're going to use if you're going no code, you gotta make the right selection when you're beginning, because like once you're beginning, you put a lot of time and effort into it, you're kind of locked in. So make sure that you can scale with it, and it's not super expensive when you scale. That's one of the problems. Security has become a big problem. We were talking about this at that advisory meeting as well. There are concerns when you use a no code platform and it's in the cloud. What is their security? Who is able to look at your data? Is your data, important, right? And you know what? Some places are really cautious with their data, so they would never take this approach, by the way. Another thing is agility. It says traditional apps are not agile. I might argue with that a little bit. I think some of them are. But no code is certainly highly agile, meaning you can quickly change how you're doing it. I think that if you're looking to integrate, you have to look at that aspect. So if you're trying to integrate your regular coding with regular systems, traditional coding might be better than no code. No coding platforms might be a little more limited in the kinds of data or systems they interface with. And the same thing with innovation. The traditional approaches are, well, they're rigid. Yeah, they are rigid. And I'm not going to say they don't encourage innovation. People still get very innovative with that stuff. But no code makes it really easy to innovate because it goes so quickly, basically. All right. I'm skipping the discussion. We're skipping the quiz. And now we're going to the fun part. And this fun part is, by the way, if you don't have to follow along with me here, I just ask that you watch at this point. But this is the extra credit thing that I threw into Unit 12. So if you guys can do one of these, I will give you extra credit for doing it. So we're going to look at Google's Teachable machine. And this is accessible through the web for free, no cost. So it uses some big open source libraries to do the work. So they use TensorFlow, and because of that particular library, it's a very popular AI library, by the way. It's very easy to integrate with websites, and you can, whatever you create, you can export it. So you can export it to like HTML and JavaScript code, or you can export it to Python code or whatever. And then depending on like the kind of device or platform you're pushing it to, you can just take the code and utilize it and do some powerful AI stuff in your apps. Now, there is a video here. I'm not going to do the video, but I would encourage you guys to watch this, and I'm doing that more for the sake of time because we have 7 minutes left. But I would encourage you to watch this video, and they just explain why this is cool, basically. So I know it's going to start, and I'm going to click past it. Okay, so I'm going to go to the website now and explore Teachable Machine. What I'm going to do at this point is I'm going to come off screen with the PowerPoint, and I'm going to show you how I got there. I'm still going to kind of use the PowerPoint to guide me, so that's going to go on the other screen because they have like kind of steps to follow. But I think I can do the steps as efficiently as that PowerPoint. So But if you guys are still looking at the slideshow, if you guys are following along on your own machine, I'm working from slide 136 on over at this point. Okay, so I'm just going to go to my browser and I'm going to type Teachable Machine. And you can see I've already been on the platform. And I'm just going to go ahead and click Started, get started. We're going to do an image project, right? But I want you to notice I can do an audio project or a pose project. And these are kind of cool, right? So you notice how like this one like follows your body, and this one can I can teach an AI with audio, right? We're going to teach it with images because it's pretty easy. When you click a new image project, it will ask you, do you want to do an embedded model or do you want to do a standard? I'm going to do a standard. So like what this one means is that, like if you're pushing it into a device, basically that has a specific kind of microcontroller, for most of you, that's not going to be the case. Now I can teach this thing to recognize images. That's basically what we're doing here. And I can teach it to recognize images a couple different ways. So I can upload a bunch of photographs. So if I have a bunch of photos, I can just upload it. There's an upload link right there. But I'm going to use my webcam. All right. Oh, shoot. This worked. I swear to God, this worked before. All right. Let's there we go. Oh, still failing. Okay, folks. Here's what I'm going to do is this is great because this worked for me earlier. This is very embarrassing in the video too, but I'm gonna pull up my friendly Firefox browser here and try going to the same thing. So let's see if this one can do it. And worst case scenario, I'll pull up my trusty webcam, and we're gonna say allow. Oh my gosh. Okay, this is not good. I'm gonna pause for a second and see if I can solve the problem. All right, so I turned off my camera feed in Zoom. I relaunched my browser. Hopefully that will be the magic trick. We'll click get started. We'll do an image project, webcam. Woohoo! All right, so now you can see my real background here. This is my plastic tablecloth from the dollar store. That's my green screen. Yeah, literally. I don't want to spend like a bunch of money on a green screen, so I spent $1.25 at the dollar store. It's off green. It's not quite green. Okay, so right now it's looking at my face, and you can see that like my hair is all messy, whatever. But I'm going to press down this button, and what it's going to do is it's going to capture my face. And just so it knows my face pretty well, I'm going to like move around and turn sideways and look up and down, right? And so watch as I do this. I'm going to start looking straight at it, turning my head, rotating, up, down, sideways, whatever. Right, so it captured 335 image samples of my face, right? So it's like a bunch of pictures, and you can see all the pictures there. You can scroll through them, right? All right, so now I need some other object to capture here. So I'm looking around my room. Oh, here we go. I have a battery tester. So here's my battery tester. And so I use this when I have batteries and I want to test them, right? So I have like a 9 volt or something or a double A and I want to test it. So I'm going to kind of like do that with it. But I'm going to do that down here. And so I'm going to try to get my face out of it because I don't want it to recognize my face, right? So I'm going to rotate the object around. So the back, the sides, whatever. Closer, farther, and that's probably about enough. All right. Now I could continue this process. So for example, if I want to add another object, here's another one. Here's a roll of masking tape. So we're going to try to do that one too. All right. So let's I'll do that here. And we're recording. So I'm trying to rotate it closer, farther. Okay, so that's enough of that one. Now, the other thing I'm going to do is I'm going to go up here and I'm going to edit the names for these. So I'm going to say my face, right? And this one is battery tester. And this one is mask or roll of masking tape. And if you guys didn't pick up on the fact, I could sample many more objects, right? And I could keep adding classes. So I could like put in a dog or a cat or whatever things I got floating around. And now that I've captured those images, now I'm going to train my model. Right. So I'm going to hit the training thing. And in the background, it's analyzing the images and looking at why my face is different from the battery tester and different from the masking tape. And it's training. And you notice it's got a bunch of different steps here to go through. And I'm not sure which thing. I've got a warning there, don't switch tabs, right? So it's like showing me what it's doing. And there is an advanced here, right? You can click on that. So you can control some of the details of the training. But notice now it's done and it's looking at my face and it's correctly analyzing that it's looking at my face. Right? How about if oh wait, now it thinks it's looking at a battery tester because my face isn't on the screen. All right, let's put the battery tester up there. Okay, so now I put it in front of my face in particular, but it knows that it's a battery tester. Let me, now I'll hold my phone up. All right, apparently everything is a battery tester, right? So I must add a lot of background. Yeah, it can't make up its mind. Well, let's get the tape up there. And there we go. Right, so we have taught the model. Well, let's confuse it a little bit. Oh, hey, which one are we looking at? That's pretty crazy, right? Now, this is all happening in the browser. I want you guys to kind of keep this in mind. This is pretty darn neat, right? Even neater, now that I've created this, I can export my model. And I want you to notice here that using the TensorFlow JavaScript library, right, it created for me JavaScript code that I could put into a web-based application and put that functionality on a website or an app that I create that's web enabled. Or if I'm working with Python, and then I want you to also notice here that they have different libraries that they're using, so they're using, in this case, they're using Keras, which is kind of what to use. This is the Python code that goes with that. And so I could take this model and add it to a Python application. Yeah, this is some crazy stuff, you guys. So I can go ahead and download my model. So like, part of the extra credit on this is screen capture, like when it gets to the end of the model, screen capture it, like recognizing an object, screen capture that, and then export the model. And you can pick any, I would probably say the Python file is the appropriate one. Download the model. And I'm not sure where it's going. I don't see it going to my download folder, but maybe it is. I got a pop up somewhere that I'm not seeing. Okay. Oh, it's converting. Okay. So it's converting the model. So it's building all the files for it. And there it goes. Right. So now I have it here as a zip file. So what I would ask, right, is basically that you give me a screenshot of it correctly recognizing objects, and then give me your model output, and then I'll give you that extra credit. What exactly is in the zip? Whatever that stuff is, right? So it's in a Keras model, which is basically Python code that I would add to an application. But you notice how easy that was, right? So this is working with a live machine learning model that does computer vision and classification. And we did a very simple example. This is some powerful stuff, you guys, and real frankly, easy to work with. I'll see if the camera feed breaks now. Okay, so now the camera feed's working in both, right? No, Zoom doesn't have a camera feed. I just turn my camera back on, and Zoom doesn't have it. So I will actually cancel the tab here, and we'll see if my camera feed comes back on Zoom. Not quite. Okay. Well, it is what it is. There we go. There we go. All right. So noted for future reference. If you're on Zoom sharing your image, you can't do machine learning through the browser. All right, folks, that's going to cap our session for tonight. I'm going to stop the recording here, and then I'll field any questions if you guys have it.